Hi and welcome back to Big Picture Technology and Science. Have you ever wondered how can it be that in a parallel circuit the total resistance is reduced when resistors are added in parallel? For example, take this circuit. If you had just R1, the total resistance would be bigger than if you had R1 and R2 in parallel. And R1 and R2 in parallel equivalent resistance is bigger than if you had R1, R2 and R3, all three resistors in parallel. Let's try to make an analogy in order to better understand this behavior. I call it the classroom analogy. Now assume there's a group of students in a classroom. Let me draw them here. Sorry for my limited drawing capabilities. A group of students that have to go in between the chairs in this corridor between the chairs in a classroom. They have to get from one side to the other side. They'll all be running through this corridor to the other side, bumping into the walls, into the chairs, bumping into one another, but they'll make it to the other side. Now assume I'll be adding another row of chairs and another corridor. So now they'll have to make it to the other side, and they have two corridors. Some would probably choose the new corridor in order to get to the other side, and overall there'll be less bumping into one another, and the way to the other side for this group of students would now be easier. And if I add yet another corridor, this time a very narrow corridor, one that lets probably one student go at a time. But still, there might be one student taking this corridor, and this student won't have to bump into the other students going into the other corridors, so even a third, very narrow corridor would still help this group of students get to the other side more easily. You probably guessed it by now. The corridors are my resistors. Three corridors in parallel are like three resistors in parallel. And as you can see, the more you add corridors in parallel, the easier it gets for this group of students to make it to the other side. And finally, going back to our electrical circuit, you can see that the more you add resistors, the more routes there will be for charges to go through when they make their way from one side of the battery to the other side of the battery. And the more you add resistors, the easier it will be overall for the charges to make their way to the other side. The total current in each one of these branches would probably be lower the more you add branches, but the overall resistance of this circuit is going to be reduced. Now, using this analogy, you can understand why the equivalent resistance in a parallel circuit is always lower than the value of the lowest resistor. That is, if we have three resistors, 5 kilo ohm, 3 kilo ohm, and 1 kilo ohm, our equivalent would be smaller than 1 kilo ohm. And that is because the smallest resistor is represented by the widest corridor, that's the 1 kilo ohm, and the biggest resistor is represented by a very narrow corridor, that's the 5 kilo ohm, and the overall resistance that these two corridors represent is smaller than even the resistance of the 1 kilo ohm.